Okay, so this class is in continuation with the geometry topic, and today we'll be discussing about triangles and different quadrilaterals. Let's first start with triangles. For triangles, we know that triangles are three-sided closed figure. When we have any three-sided closed figure, this is triangle ABC. So for any three-sided closed figure, the angle property is, in a triangle we have three different angles. So the property about triangles is sum of triangle is 180. Sum of triangle is 180 means angle A plus angle B plus angle C. All these three angles should sum up to 180 degrees. That is the first property to be remembered generally about triangles. And then in triangles, we have a few special types of triangles to be remembered. One of those special triangle is isosceles triangle. So isosceles triangles are the ones in which we have two angles or two sides same. And the indication for isosceles triangle is we see this dash sign. So these dash on the two sides, they indicate that the two sides are equal. If let's say this is ABC, so in case of AB, the side AC and BC would be equals. So for isosceles triangle, we always have two equal sides and two equal angles. And what angles are equal? The angles opposite to the equal sides are equal. Angle opposite to the equal side means opposite to BC, we have angle A, and opposite to AC, we have angle B. So that means opposite to AC, we have angle A is same as opposite to angle BC, which is angle A, and then opposite to AC. Sorry, I wrote this wrong. Opposite to AC, we have angle B. And opposite to BC, we have angle A. So angle B and angle A are equal. So for example, if angle A is X, angle B will also be X. That's the first type of spatial triangle in our syllabus. Then we have one more spatial type of triangle, which we call as the equilateral triangle. For equilateral triangle, as we have the word equal being used here, so for equilateral triangle, if this is A, B, and C, in equilateral triangle, all three sides are same. So if all three sides are same, they should be having single dash on all three sides. And then it's not necessary that all these sides would be represented by single dash. There can be double dash also. Whatever they are being represented, you just need to be sure that all the three sides are being represented by same thing. Either all three are having the single dash or all three are having the double dash. So we have all three sides equal. So we have AB same as BC, same as AC. Since we have all three sides same, so angles opposite to all three sides will also be same, which means angle A is same as angle B is same as angle C. And in case of equilateral triangle, it's a must thing. All three angles are 60. That's a must thing about equilateral triangles. In equilateral triangles, all three angles are always 60 degrees. Because we know that sum of a triangle is 180. And if all three angles are same, so 180 divided by 3 would give us a 60. So in case of equilateral triangles, all three angles are always 60 degrees. And then we have another spatial triangle, which we call as a right angled triangle. In right angled triangle, one of the angles should be 90 degrees. So if this is ABC, we can see that we have a 90 degree at angle B. So for right angle triangles, one angle is 90 degree and this is the indication of 90 degrees. It's a must thing. So if I make another right angle, let's say this is PQR. And if Q is a 90 degree, so 90 degrees is always indicated by this small square. So these are the three spatial type of triangles in our syllabus. Okay, we'll use all these properties here to solve a few questions. The part A, in this question, we have to find the values of each of these following figures. Part A, if we have to solve. In case of part A, we can easily make the equation as we have three angles given, 2x, 82 and 46. So we can make the equation as 2x plus 82 plus 46 is equal to 180. And then 2x is equal to 180 minus 82 and 46. So that should be equals to that's 52 and x is equal to 52 upon 2, which is 26. So we get x as 26. Part B. Part B, here you can see in case of part B, it's an indication of isosceles. And for isosceles, we know that two angles are always same. And you have to be clear about which two angles are same. So it's always the angles opposite to the equal sides. Opposite to the equal sides means opposite to this equal side, this is 58. So opposite to the another equal side, this angle, this will also be 58. So here we'll make the equation as 58 plus 58 plus x is equal to 180. And then x is equal to 180 minus 58 plus 58. We get this as 64. So the value of x here is 64 degrees. Let's talk about part D. Part C is pretty much same. Part D. In case of part D, double dash and double dash. So the angles opposite to the equal sides are same. So here we can say that this 3x is same thing as 63, and that would eventually give us x. So x is equal to 63 upon 3. We get x as 21. So this was all about sum of triangles and isosceles triangles. Moving onwards, we have these another set of questions. And here we would be using a mix of concepts. Mix of concepts means the concepts we learned in the previous class about straight lines and the concepts learned today about the triangles. So we'll be using both the concepts together to solve these questions because here it clearly says DAB and EAC are the straight lines. So these are the straight lines. So we have to apply the properties of straight lines. And this also includes the triangle. So it has to be the mix of both the straight line properties as well as the triangle properties. In case of part A, if this is 123 degrees and it's a straight line, DAB as the question itself says, because of the straight line, this would be 180 minus 123 and 180 minus 123, that's a 57. And we have got inside the triangle, this is 57. And with 57 known inside the triangle, we can now make the equation here. So it's 57 plus x plus 39 is equal to 180. So these are the three angles inside. So this is 57, x and 39. So x can be found as 180 minus 39 and this 57. X would be equals to this is 84. In the same way, we'll work it out for part B. Now, part B, we have two unknowns to be found, x and y. And this second unknown y that is outside the triangle. With this angle, which is outside, this is also called as exterior angle. Why exterior? Because this is lying outside the bounded figure. This angle is called as the exterior angle. To reach to the exterior angle, we first need to solve the interior angle, the angles which are there inside the triangle. And looking at the angles inside the triangle, we can make the equation as 40 plus 3x plus 4x is equal to 180. We have made the use of these three inside angles. So 40 plus 7x is equal to 180. 7x is equal to 180 minus 40, that's a 140. X is equal to 140 upon 7, which is 20 degrees. So this is how we have found the value of x as 20. And now this y to be found, this y is an exterior angle and it's lying on the straight line. This is the straight line DAB. And whenever we have an angle on the straight line, we can use the straight line property, which is this y plus 40 is equal to 180 and y is equal to 180 minus 40, which gives us y as 140 degrees. Now in these two questions, It's a mix of a few more properties. In the previous video, we have talked about parallel lines also. So here we can see a lot of things involved. We have the parallel lines being seen. Part C, parallel lines are there. We have to keep in mind the properties of the parallel lines. We can also see the double dash involved. That means you have to keep in mind the property of the isosceles triangle. And these are also the straight lines involved. So you have to keep the properties of straight lines also in mind while solving the question. So it's a mix of different geometrical properties and different geometrical properties to be applied in case of this one single question. So we'll apply all those properties one by one. Okay, first thing first. So we see an indication of the isosceles. And for isosceles, we know that angles opposite to the equal side are equal. So this double dash having opposite as x. So this double dash will also be having the opposite as x. So this angle is also an x for us. And then we see a letter Z being formed. And because of this letter Z, if this is angle x, so because of letter Z, this will also be letter x, this angle x, because of letter Z. So we have got this angle also as x. Now the equation to be made here is, now look at this complete triangle, triangle ACD. Focus on the triangle ACD. When you are focusing on one triangle, make sure you're ignoring the other things inside. Now, if you were focus on this whole triangle ACD as a whole, so how many angles we have involved in this figure? Only look at the cornered angles. We have this corner as 63, this corner as x, and this corner as x plus x, which is a 2x. So the first equation to be made here, it would be 63 plus x plus 2x is equals to 180. So 63 plus 3x is equal to 180. 3x is equal to 180 minus 63. And 3x is equal to 180 minus 63. That is 117. X is equal to 117 upon 3. That gives x as 39. So we have got the value of x here. This was all about part C. We just need to find the value of x. Now let's move on for part D here. Part D here, again, we see a mix of different geometrical properties applied. We see triangles here. We see parallel lines here. So all these things and all these properties can be seen here. So we have to make sure that we focus on one property at a time. If we have to focus on one property at a time, so what we're gonna do is we see first this letter Z involved. Because of parallel lines, this is the letter Z. Because of this letter Z, if this is 58, so this will also be 58. This is 58. Now this BCD is a straight line. If BCD is a straight line, we can apply the property of straight line. And this will help us in finding this remaining part of the straight line. So this remaining part, it would be 180 minus 79, which is 101. So now focus on this triangle ABC. In ABC, we have angle A as X, angle B as 58, and angle C we just found as 101. And all these three angles should sum up to 180. So X can be found as 180 minus 101 and 58. That gives us as 21 degrees. We've got the value of X here, which is 21. After solving this triangle ABC, our focus should be on finding the angle Y now. And angle Y is here. Angle Y, we can see it's a part of the triangle ACD. So now all your focus should be there on triangle ACD, triangle ACD. In case of this triangle ACD, we have angle A as Y plus angle C as 79 plus angle D, it's a 3x, and all these three angles should sum up to 180. We have already found the value of X, so this value of X found 21 would be used in the equation. So we'll get the equation as Y plus 79 plus 3 into 21, that gives us 180. So Y plus 79 plus 3 into 21, that's a 63 is equals to 180. And Y is equals to 180 minus 63 minus 79. So 180 minus 63 minus 79, that gives us Y as 38. So this is how we find the values of X and Y. And we use all the properties of triangles, parallel lines, and straight lines. Okay, so these were a few practice questions along with the answers, and I'm sure you would have got all of these correct. There were 4 parts for question 4 and the parts, and the answers also there. So do practice it.